Section 17.1, the common ion effect. In Chapter 16, we examine the equilibrium concentrations of ions in solutions containing a weak acid and a weak base. We'll now consider solutions that contain a weak acid, such as acetic acid, and a soluble salt of that acid, such as sodium acetate. Notice that the solutions contain two substances that share a common ion, acetate. It's instructive to view these solutions as predictive of Le Chatelier's principle. Sodium acetate is a soluble ionic compound and is therefore a strong electrolyte. Consequently, it dissociates completely in an aqueous solution to form sodium and acetate ions. In contrast, acetic acid is a weak electrolyte that ionizes as follows. The acetate from sodium acetate causes an equilibrium to shift to the left, therefore decreasing the equilibrium concentration of protons. In other words, the presence of an added acetate ion causes the acetic acid to ionize less than it normally would. Whenever a weak electrolyte and a strong electrolyte contain a common ion, the weak electrolyte ionizes as if it were alone in the solution. We call this observation the common ion effect. Sample exercises 17.1 and 2 illustrate how the equilibrium concentrations may be calculated when a solution contains the mixture of a weak electrolyte and a strong electrolyte that have a common ion. The procedures are similar to those encountered for weak acids and weak bases in Chapter 16. Sample exercises 17.1 and 2 also both involve weak acids. The ionization of a weak base is also decreased by the addition of a common ion. For example, the addition of ammonium, as from the strong electron ammonium chloride, causes the base dissociation equilibrium of ammonia to shift to the left, decreasing the equilibrium concentration of hydroxide and lowering the pH.